Did you know that your brain can transfer information across different areas, similarly to how sound can cross a room? Like sound, your brain is able to transmit millions of waves at a time and send important signals that can result into tangible actions like thoughts or movements. There's three types of waves, or oscillations, in the brain. First, individual neurons can produce small oscillations within their cell body in order to send an electrical signal to the next neuron. A group of neurons, though, can synchronize their electrical activity and add up their waves via interference. Lastly, oscillations can arise from the interactions between different brain areas. To describe the wave property of brain waves, it's easier to focus on the oscillations created by a group of neurons. This type of wave is like a standing wave because it doesn't appear to move, but rather the neurons just vibrate in place. Neurons can only communicate in a single identical buzz. Therefore, the amplitude and wavelength must be the same and create interference. Interference is the overlap of two or more waves at the same point in time, and superposition is the combination of two waves at the same location. The superposition of brain waves resembles constructive interference because the two waves are theoretically identical. The resultant brainwave will be one with double the amplitude but maintain the same wavelength and form resonant standing waves. The brain has 5 of these waves that differ by their amplitude and frequencies. The amplitude is the maximum height of the wave from the neuron's equilibrium position. The frequency is the number of times the neuron fires per second and is measured in hertz. The first is the gamma brainwave, and it's the fastest measurable wave. It's associated with a heightened perception, learning, and problem-solving tasks. We only typically have this brainwaves for a couple of seconds when we're concentrating really hard. The second is the beta brainwave, which is detectable when we actively think. It usually begins once we wake and begin a normal state of alert consciousness. Then comes the alpha brainwave, which is most easily observable and was first to be discovered. It's usually most active when we're physically and mentally relaxed. Theta brainwave is most detectable during dream or sleep, and similarly, though less common, the delta brainwave occurs during restorative sleep in a dreamless state. The frequency and amplitude of the waves determine their activity level in the brain. Brainwaves with a higher frequency but lower amplitude will have a fast activity, and on the other hand, waves with lower frequency and higher amplitude will have a slow activity. Even though these brainwaves have been separated by cognitive function, in reality, one brainwave is never occurring alone. Rather, multiple waves exist simultaneously, but one may be more abundant depending on your state and the task on hand. In all honesty, we don't fully understand the extent of these rhythms or brainwaves. However, a popular notion is that this synchronized firing allows our brain to better communicate across different regions and can be explained using resonance. Resonance is a specific type of motion that's understood to be a synchronized oscillation between two states. This means that the small amplitude driving forces can produce a large amplitude motion, and that's exactly what brainwaves are. The energy and power of a wave are proportional to amplitude, thus resonant waves contain more energy. Resonance is very special because it allows two systems to transfer this energy between each other if they vibrate with the same resonant frequency. Although the brain is a complex anatomical structure, it's contained within a small space, and an interesting phenomenon occurs when different vibrating objects are close. They will start vibrating together at the same frequency. If that's the case, then the brain creates the perfect condition for resonance, and it may explain how the brain can communicate non-synaptically, and as scientists are trying to uncover, maybe even across different brains. So anytime you're awake, or not, you can think about all the amazing activity that goes on in your brain at all times.